Hello, everyone. So, today for chapter 17, we will be talking about reliability. So, to get things started off with us today, we've got a little intro. It says here, does Briggs and Stratton make a heart monitor? Their small engines are very reliable. So, I thought that was a funny little reliability meme there. But let's hop straight into our objectives for this chapter. Our objectives are to be able to differentiate between test reliability and score reliability. Define the three different methods of estimating score reliability. Describe procedures used to estimate, test, retest, score reliability. Describe procedures used to estimate alternate form score reliability. Identify situations in which test, retest, or alternate form score reliability is most appropriate. Describe procedures used to compute split half and Cooter-Richardson estimate of internal consistency. Describe how the Spearman-Brown-Provisi formula is used and its effect on the reliability coefficient. Compare and contrast power and speeded tests and their relationship to score reliability. But however, that is not all our objectives for this short chapter. There are more. Discuss the pros and cons of using only internal consistency score validity estimates. Apply the principles provided in the text to interpret score reliability coefficients. Explain why group heterogeneity affects score reliability coefficients. Explain why longer tests tend to be more reliable than shorter tests. Explain why different estimates of reliability will yield different reliability coefficients for the same test. Select the best test for a given purpose when provided with the score reliability information for different tests. Select the best test for a given purpose when given score reliability and validity evidence for several tests. And lastly, now, identify the most appropriate type of score reliability when given different purposes for testing. Now, to go into the contents of chapter 17, we first got to be able to have a definition of reliability. So, what is the reliability of a test? The reliability of a test refers to the consistency with which it yields the same rank for individuals who take the test more than once. In other words, a test is reliable if it is consistently yields the same or nearly the same ranks over repeated administrations during which we would not expect the trait being measured to have changed. Here we've got a little picture. The only 100% reliable psychological examination you will ever need. Are you insane? Yes or no? Now that we have a baseline of reliability and testing and the definition, we can go straight into methods of estimating score reliability. And there are a few of them. The first one we will discuss here is test, retest, or stability. What is it? Test retest is a method of estimating score reliability that is exactly what its name implies. The test is given twice, and the correlation between the test set of scores and the second set of scores is determined. Over to the left, we have an image that is a visualization of the definition. We have the first test at the beginning of the timeline and a second test at the end of the timeline. On to our next method, which is alternate forms or equivalence. And this is obtained by administrating two alternate or equivalent forms of a test to the same group and correlating the scores. The time interval between the testing is to be as short as possible. Over to the right, alternate forms of reliability. This compares subjects' answers to slightly different versions of the survey questions, may reverse the order of the response choices in an index, or modify the question wording in minor ways, and then re-administer the index to the subjects. If the two sets of responses are not too different, alternate forms reliability is then established. Continuing on to our third, internal consistency. This is more of a generalized term, which other methods are listed under. So, what is internal consistency? Internal consistency estimates of score reliability fall into two general categories, which I was talking about, which is split half, which we will cover here shortly, and then item total correlations. These estimates should be used only when the test measures a single or unitary trait. Now, the first method that is under this is used to find the split half odds even reliability. So split half methods. Each item is assigned to one half of the test or the other. Then the total score for each student on each half is determined, and the correlation between the two scores for both halves is compared. Essentially, a single test is used to make two shorter alternate forms. So over to the left, we have a visualization of the split half methods, where item 2, 3, and 5 is correlated against item 2, 4, and 6, your odds and your evens, and then we're able to get a correlation between the one test and the testing items. Moving forward, we have the Spearman-Brown. And what is the Spearman-Brown? A Spearman-Brown is a privacy formula that is most associated with the split half method. However, this can be used whenever a test developer wants to estimate the effects of lengthening or shortening a test based on its reliability coefficient. So, again, we got another definition to the Spearman-Brown over to the right, which I trust you can pause and read. But I also wanted to include this image in this because it also shows the equation for the Spearman-Brown, which our book also covers, but it also breaks down the parts of the equation in this image. Moving forward with our next is the Cooter-Richardson methods. And this is another way of estimating the internal consistency of a test. These methods measure the extent to which items within one form of the test have as much in common with another, as do the items in that one form with corresponding items in the equivalent form. It is like doing a split half reliability on all combinations of items resulting from different splitting of the test. So again, we have another definition of the Cooter-Richardson formula. And we also have the formula listed over here to the right. Again, the formula is listed in our book, but again, this picture over here breaks down each of these symbols and how to plug into the equation here. And that concludes us with our methods for this chapter of determining reliability. We are now going to move on into interpreting reliability coefficients. And in interpreting reliability coefficients, our book gives us 4 principles in which we can interpret. And this is exactly what we are going to go over. Our first principle is group variability affects the size of the reliability coefficient. The higher the coefficients results from heterogeneous groups than from homogeneous groups. And I also included an image down here for when you calculate your reliability coefficients and the interpretation of the number that you get based on reliability. Moving to principle 2, scoring reliability limits test score. Reliability. If tests are scored unreliable, error is introduced that will limit the reliability of test scores. Based on this principle, I also included an image over here to the right of ways of obtaining score reliability. Here you can use items that permit scoring, which is as objective as possible. You can train scores. You can make comparisons between candidates as direct as possible. You can agree to acceptable responses and appropriate scores at outset of scoring. Employ multiple independent scoring. You can provide a detailed scoring key. And you can identify candidates by number, not name. And that is ways of obtaining score reliability. Moving forward to principle number 3. Principle number 3 states, all other factors being equal, the more items included for a test, the higher the reliability of the scores. And lastly, principle 4. Principle 4 states, reliability of test scores tend to decrease as tests become too easy or too difficult. And with that, that concludes our presentation of Chapter 17, Reliability. All right, I hope you learned something, and I look forward to your feedback. Thank you, and thanks for watching.